Assalamu alaikum. How are you, dear students? Welcome to the channel, The Physics Gurus. So, here we are on the episode number 13 of the definitions of O-level physics and IGCSE physics of the syllabus 2022. So, in this episode, we will discuss some major and important definition regarding the unit number 26 and 27, that is radioactivity and the nuclear atom. And these definitions are very important in this respect that usually in section B of the theory paper, a long question is being asked carrying 15 marks. So learn these definitions very precisely so that you may get 100% marks in that part. So let's start the definitions of unit number 26 and 27. So the first of all, the definition of atom. Atoms are the basic units of matter and defining the structure. So the basic element is the atom, and these are the basic units of the matter and defining the structure of elements. So every element has different number of atoms. So now here I am going to draw the diagram over here. So the central part of atom is called as nucleus. Central part of atom is called as nucleus. Nucleus carries protons and neutrons, and these are called as nucleons. And these are called as nucleons. The particles which revolve around the nucleus are called as electrons. The charge on the nucleus is positive charge. What is the reason? Because protons are positively charged particles and neutrons are neutral. But the charge on atom is a neutral particle. And what is the reason? Because the number of electrons orbiting around the nucleus are equal to the number of protons. So how many protons are there? 2. And how many electrons are there? 2. So equal quantity of positive charge and equal quantity of negative charge is there. So they will cancel out each other effects. So this is the reason atom is called as neutral particle. And what is the reason? Because number of electrons are equal to number of protons, and electrons carry negative charges and protons carry positive charges. Then here comes the next definition, and the definition is the definition of atomic number, charge number, or proton number. Now, what is meant by atomic number, charge number, or proton number? It is always represented by capital Z. The symbol of proton number, charge number, atomic number is capital Z, and it is the number of protons in nucleus. It is compulsory that whenever you are supposed to write down the definition of atomic number, charge number, or proton number, always mention the number of protons in nucleus. Never ever write the definition like this, that number of protons are called as atomic number, charge number, or proton numbers. To be on the safer side, to be very precise, you have to mention the number of protons in nucleus. The second definition related to this topic is the definition of nucleon number or atomic mass number. It is represented by capital A. The sum of protons and neutrons, where in the nucleus, is called as nucleon number or atomic mass number. So these are the two major definitions. Number one, atomic number, charge number, proton number represented by capital Z. So number of protons in nucleus is called as atomic number, charge number or proton number, and Z is equal to number of protons, and number of protons are represented by capital P. Nucleon number, atomic mass number is represented by capital A, and what is its definition? The sum of protons and neutrons. in nucleus is called as nucleon number or atomic number. It is represented by capital A, and this will be equals to protons plus neutrons. And what is the definition of neutron number? Neutron number is represented by capital N. So the number of neutrons in nucleus. Now we are having Z, we are having A. So how we can calculate number of neutrons? By subtracting Z from A. So number of neutrons can be calculated by this formula. Number of neutrons is equal to atomic mass number minus atomic number or charge number. Then here comes the excuse me, another definition, that is nucleate notation. The method to write the symbols in the following way is called as nucleate notation. Capital X, A and Z. Capital X represents the symbol of element. Capital A, atomic mass number, and capital Z represents atomic number. Sometimes we have to write down the nucleate notation when value of A and Z is given. So according to that, we can write the nucleate notation. Let's suppose if it is given that Na 1123. So X will be represented by Na, sodium. 23 will gives the value of atomic mass number, and 11 will give the value of charge number. So how you can define the structure of sodium? That there are 11 protons in the nucleus. There are 11 electrons revolving around nucleus. And there are, what we will do in order to calculate the number of neutrons, 23 minus 11. So there are 12 neutrons in nucleus. So usually this question is asked for the 3 marks, and you have to mention the nucleus word for number of protons and number of neutrons. And for electrons, you have to mention that there are 11 electrons revolving around the nucleus. And why number of electrons are equal? Can anyone comment why number of electrons are equal to the number of protons? If you know the answer, please comment. Okay, then isotopes. Isotopes are the elements having same number of protons but different number of neutrons. Let's suppose 1H1, 1H2, 1H3. So for 1H1, number of protons equals to 1 and number of neutrons equals to 0, because A minus Z. So the value will be equals to 0. Then here comes the definition of 1H2, and what will be its structure? Number of protons will be equals to 1 and number of neutrons will be equal to 2 minus 1 is equal to 1. Now can anyone tell the structure of 1H3, that how many protons are there and how many neutrons are there? So if we will compare these two values, then number of protons are equal to 1 and number of neutrons are different. In 1H1 there is no neutron, while in 1H2 there is 1 neutron. So if you know the number of protons and number of neutrons in 1H3, do comment. Okay. Then result of Giger-Marsden alpha particle scattering experiment is the very famous experiment, and here we are using the alpha rays, and alpha rays are represented by positive charge, or alpha rays carry positive charge. So in this experiment, what are the results? So you have to learn the result of this experiment, number one, the existence of smallest nucleus, that is, the size of the nucleus is smaller than the size of the atom because nucleus is confined within the atom, or atom consists of mostly empty spaces. Due to that, most of the alpha particles moves in the straight path or undeviated, or atom consists of small spaces but with positive nucleus. Now how we can determine that positive nucleus? That if nucleus is over there, then the alpha rays which are passing nearer to the nucleus will definitely deviate their path because like charges repel each other. Or it is the existence of dense nucleus in the atom, or last one you can write also like this, existence of nuclear atom. Then very important definition of background radiation. The radiation present all the time in atmosphere is called as background radiation. Let's suppose if we have a detector, and first of all, what is the definition of detector? A device used to detect radiation. Then a very famous detector is Giger-Muller tube, or you can write it like this, GM tube. If there is a detector placed in the room, and when we will switch on that detector, still it will show some sort of reading. Its main case is detecting some sort of radiation, but in room there is no radioactive material or the source. Then why it is showing some sort of reading? So this is due to the background radiation, the radiation which are present all the time in atmosphere, and the possible sources are in rocks, radiation can be there, soil, nearby nuclear power plant, from there radiation can be leaked out, nuclear fallout, and the major source of the background radiation is sometimes are the cosmic radiations, and these are the radiations which are present all the time and everywhere. So background radiations are very important radiations. Then here comes the next definition, and the definition of radioactive decay. So what is meant by radioactive decay? So you have to write down this definition as it is: the process of emission of any type of radiation. You have to mention alpha, beta, or gamma, because there are three types of radiations: alpha, beta, and gamma, from nucleus. This is the compulsory part of the definition, and converts into the new element. So what does it mean? Whenever there is a radioactive decay, particularly for the alpha and beta, and then after emission of these type of rays, the element which was emitting the radiation will be converted into the new element. So this is called as radioactive decay. Then an important term, half-life, is there. So what is a half-life? The time during which number of atoms, you can write any of the following: number of atoms, count rate, activity rate, or number of nuclei to becomes 1/2. It is not the time period. You are not supposed to write it like this. It is the time period. No. It is the time during which, and some students are doing mistake over here. What they are supposed to write, the time during which mass of the element, mass of the atom. No, you are never ever supposed to write down the term mass. So you can pick any of the terms. The time during which number of atoms, count rate, activity rate, or number of nuclei becomes 1/2. Then that time is called as half-life. And how we can calculate the number of half-lives? So its formula is very simple: time to observe divided by half-life. Let's suppose in the question it is given that we are observing the element for 500 years and its half-life was 100. So we have to calculate the number of half-lives. So time to observe will be 500. It will be divided by 100. So then this will be, number of half-lives will be 5. So in this way we can calculate the number of half-lives. So it varies from question to question as well. Then here comes very important part of the nuclear physics, that is alpha decay. The generalized opinion of alpha decay is XAZ. Okay, alpha can be represented by 2 alpha 4, or it is equivalent to 2 helium 4. So the nature of alpha particle is similar to the nature of helium nucleus. So this is the reason we can write helium or we can write alpha, but with the same values in both of the symbols 2 4 and 2 4. So now what is happening? When an element emits the alpha particles, then the new element has some different values for A and Z. In the new element, value of A will be reduced by 4 and value of Z will be reduced by 2. For example, let's suppose that X is equal to 234 and this is equals to 98, and it is now emitting alpha particle 2 4. Then for the new element, now what will happen? 234 minus 4 is equal to 230. So we will write 230 over here, and 98 minus 2 is equal to 96. So in the new element, now the values are 96 and 230. Another example, if let's suppose X is 220 and Z is 90. Now, can anyone tell what will be the value of A for Y and what will be the value of Z for Y? If you know the answer, write your answer in comments. 220 and 90. For beta decay, now you can easily understand that what is happening in beta decay. Okay, beta particles can be represented by beta minus 1 0 because they carry negative charges, and these are the electrons emitted from the nucleus. So beta particles are the electrons emitted from nucleus, or beta particles can also be represented by minus 1 0. Now you can see that when an element emits the beta particles or electrons, because these two are similar, so what is happening over here? Value of A remains as it is and value of Z is increased by 1. So let's suppose example consider करते हैं 230 and then let's suppose 21. Beta negative 1 0 plus Y. Okay, value of A remains as it is 230 and value of Z will be increased by 1. So we have to write down over here 21 plus 2, sorry, plus 1, then this will be equal to 22. Some students are doing blunder over here. What they are doing, 21 minus 1 is equal to 20. Now, as in chemical reactions, equations are always balanced. So likewise, in these type of reactions, equations are also balanced. 230 plus 0. 230 plus 0, then this will give you the value 230, and 22 minus 1, this will give you the value equals to 21. And if you will write 20 over here, then 20 minus 1, this will be equals to 19 and your equation will be crossed. So let's consider another example. X 200, then this will be, this value can be 98. It is emitting negative 1 0 plus Y. Now can anyone tell what will be the value of A and what will be the value of Z? So let's move towards the third type of decay, that is gamma. Since gamma are neutral, so in their mass is, and they are high frequency electromagnetic waves emitted from nucleus. So gamma rays will be represented by 0, 0. And now you can easily conclude the result that whenever gamma rays are emitted, then here you have to write down the X, then there will be no change in the element and web because value of A and value of Z remains as it is. So in this way, you can say that let's suppose if this is 230, this is 98, and it is emitting gamma rays plus X, then X remains as it is 230, 98. Only it will emit high frequency electromagnetic waves because electrons will jump from higher orbit to lower orbit by releasing the huge amount of energy. Then here comes the last two definitions of this chapter. Nuclear fission reaction. When an atom, heavy atom, divides into two or more smaller or lighter atoms or nuclei with the release of huge amount of energy. Let's suppose if you have the uranium, when it is bombarded with neutrons, then uranium will be split into barium plus krypton, lighter nuclei, plus 3 neutrons are over there with release of huge amount of energy. So this process is called as nuclear fission reaction, and this process can be controlled in nuclear power plant, and the energy which is produced as a result of this reaction can be used to produce electricity. Then nuclear fusion reaction. This reaction is opposite to the nuclear fission reaction. In nuclear fission reaction, a heavy nucleus splits into two lighter nuclei, while in nuclear fusion reaction, two lighter nuclei fused or joined together to form a larger heavy nucleus with release of huge amount of energy. Let's suppose if we have 1H2 lighter nuclei, 1H3 lighter nuclei, when these two nuclei will go under through the process of fusion, then helium will be formed. It is a heavy nucleus, and neutron will be emitted as well, plus huge amount of energy will be released along with this. So in nuclear fusion reaction, smaller nuclei or atoms fused or joined together to form the heavy nucleus with the release of huge amount of energy, and nuclear fusion reaction is responsible for producing energy on the surface of sun, on the surface of stars. So best of luck to all of you. Thank you very much for watching the videos under the channel of the Physics Gurus. Always stay blessed. And if there are any questions, you may please write that question in the comment portion, or you can WhatsApp your questions. Thank you very much and best of luck.